In this video, I'm going to go through an example about how you can transform or interpret logarithmic graphs. So this is all before even doing any of the logarithm using logarithms laws and converting between exponentials and logs. But what you need to remember is that if I have a function a to the power of x, then the inverse of it is log with the base of a, and then x is there in the log. So what I do want to explain on the side is how to use this on a calculator. So if you have a GDC calculator, you can find logs on in one of the options buttons. Let me discuss the... So on a GDC calculator, you'll find it right underneath x squared. So there's a x squared button, and then you'll have the log button. But this is just a log to the base 10. So this is by default a base 10. If you want a more logs to more powers, then you'll have to go through math. You'll have to press on math and then go to scroll all the way down until you find log base, and then you have to pick a different base, and we'll be dealing with this later on. But you can use this just in case you want to graph your function. And if you have a scientific calculator, then you should have a button for log, and again, if you just press the log, then it's automatically a base of 10. You should have another button where it goes log and then square, and this means you can add any base that you want. So for this logarithmic function, the first part is, which is the focal point of this video, is the transformation. So I want to know the necessary transformation to move g of x onto f of x. So we are moving this to that, and this is our basic logarithmic function. So log base of 10x. And we've discussed some of the transformations here. So if I have a log, let's keep it a base of 10, x minus h plus k. This is the most basic transformation. And what this does is a vertical shift, and this does a horizontal shift. So it means that if I want to, if I want to answer part A, if I want to transform log of 10x onto this one, I first have to make a horizontal shift, or let's say translation, more precise wording, translation to the right by 2. So keeping in mind that whenever you have this type of transformation, you are going to move it to the opposite sign. So if it's negative h, it means you're moving it to the right by h. If it's going to be a positive number, so if this was a positive 2, then you're moving it to the left by 2. So keep in mind that the direction is the opposite. And then if I'm adding this one, then I have a vertical translation upwards by 1. So quite easy to transform the graph and very straightforward. For part B, if I want the equation of the asymptote of f, the asymptotes are the values that wouldn't work inside your f of x. And for logarithmic functions, you only have vertical asymptotes. You don't have vertical asymptotes. So for the ones we're going to deal with now, you don't have a horizontal asymptote. The vertical asymptote comes from the inverse function. So we can think about it two ways. One, the vertical asymptote is everything that is restricted from the domain. And if you try to plug in a few values in here, you'll notice that x equals to 2 would give you an error, which means the vertical asymptote is x equals to 2. You can also think of it the other way, that the vertical asymptote comes from the horizontal asymptote of the inverse function. And the inverse of this is a complicated exponential function. So I'm not going to go through it. If you want to go through it, you can try and check that the exponential function's horizontal asymptote will be your vertical asymptote in this case. So if we did do the f inverse, we would have gotten a horizontal asymptote of y equals to 2, and therefore the vertical asymptote is x equals to 2. The reason I'm not going to go through this is if you have this background of converting logarithms to exponentials, use it to check. Otherwise, we can stick with just this knowledge that this is the restricted domain. The reason for this is that logarithms don't take an input of 0. So what's input, it's like dividing by 0 kind of rule. So if you plug in log of 0 in a calculator, you'll get an error. So I'm not allowed to have a 0 in here. So the only time I'm going to get a 0 is when x equals to 2. So that's an important fact to know. So that would create my vertical asymptote, which helps me create my domain and range. So domain is now everything bigger than my vertical asymptote. So x bigger than 2. And you could say x belongs to the real numbers. And then the range is not restricted for the logarithms. The range is just all the real numbers. So straightforward here. So this was an important take on the on part B. So now I need to sketch f of x and the line y equals to x, and hence I need to sketch f of inverse of x. The fact that they said hence means that you don't need to find the exponential function. You don't need to find the inverse. You just need to use the y equals to x line. And this is a sketch. So if you just graph in a v values, you'll be able to see how your function behaves. So if I just 3, 4, say, tiny, and -1, -2, -4, -6, and so on. And then I'll use the same 1, 2. Okay. So if I'm graphing my original function, first I need to understand the behavior that it does throughout all the points. So I know that x equals to 2 is a vertical asymptote, and so I'm not allowed to use any function below. One more extra point to bring here: logarithm functions don't take an input of 0 or less. So they don't take negative inputs as well. And again, you can try these in a calculator, so you'll still get an error. So your input in logarithm functions has to be, so this x minus 2 inside here has to be bigger than 0, which means I won't be able to use any of the numbers here because it's going to give me a negative. And you can test the behavior of the function as it gets very close to 2. So let's say from this side, so let's say 2.000001, and you'll notice that you're going to get a very negative infinite number. And then as your x increases, your function is going to increase as well. So we have, before I go, I also need to know when does it actually cross the x-axis. So when will it give me an output of 0? And you can try it through a table. You can try a few values in there. If you have just basic knowledge of logarithms, then don't worry. You can just use trial and error. If you know facts about logarithms, you'll know which values to input in, and you'll find that 2.1 will give you the x-intercept. So we need this 2.1 here. So I'm reaching from infinity to 2.1, and then this type of behavior. And so if I have my x equals to y graph, then, so this is y equals to x, sorry, and I'm going to reflect it to get f of inverse. And remember that the vertical asymptote becomes the horizontal asymptote. So I have this behavior. It's gonna cross now 0, 2.1. So I have this 2.1 here, and it's an exponential function, so it's gonna keep on increasing as it goes upwards. So I have, this is a very bad curve. So something like this. Obviously, you'll have to make it seem like they're reflecting, and that's your f of inverse. So the intercepts are important. The vertical and horizontal asymptotes are important in here as well. One thing to point about the asymptotes as well. In general, you should know that a log 10 of x has a vertical asymptote of x equals to 0. Now, because we're doing a shift of -2, or a shift of 2 to the right, then this will also shift to the right by 2, which means this is how we get the x equals to 2 vertical asymptote. So that's another way of looking at this. So just to bring everything all together at once. So hopefully this video was clear, just using basic knowledge of logarithms, not even about converting bases or changing it to exponentials.